Hey, Chris here. Today we're launching a very exciting new course. For the past 1.5 years, by far the most requested topic by you guys was Apex, the new rigging and animation system in Houdini, and SideFX's new favorite thing in general. And believe us, we tried making an Apex course for you, multiple times. But we are motion design and FX guys, not animators or riggers. And without that knowledge, we just couldn't do Apex justice. So today, I'm really happy to announce we finally found an animator and rigger and Apex Pro in general. We got Magnus Møller from Tumblehead Animation to create an Apex beginner series for us. Magnus and Tumblehead have been animating in Houdini for a very long time. You've seen their work in multiple Houdini keynotes, and they contributed a ton of feedback to the development of Apex. We literally can't think of someone better suited for this course. So let's talk schedule. For now, this will be a 3-part series that will publish in a typical bi-weekly schedule entirely for free here on YouTube. It'll provide the fundamental know-how of how Apex works so that you can eventually build your own tools and setups from scratch. In this first video, Magnus will guide you through creating your first Apex graphs and do a little deep dive into how Apex works and how it differs from SOPs. In the second video, you'll learn how to rig your first character in Apex, and in the third video, Magnus will give you your first intro into the deep world of Apex script. Finally, if you like this series, please let us know in the comments and on social media. We'd love to create more Apex training with Magnus in the future, and we want to hear your feedback. But with this, it's time for me to hand it over to Magnus. Let's go.
Hello and welcome to this introduction video to Apex. And this video will have a look at how we can build something like this entirely with an Apex graph. I've prepared a few examples here, but let's jump to the first one to get started. So you see here you have just a normal box, and I have added a point VOP where I add a random value to each point, write that out as the new position, and voila, the box have changed. So in VOPs, you make the graph inside of your VOP network. This graph then outputs new values and write that to the geometry. And the output of every node in SOPs is obviously geometry. So the graph here is kind of forgotten, or there is no access to it outside of the VOP node. Apex is very different. So even though it looks like a VOP network, the way it works is a very different kind of design. So to do anything in Apex, first of all, we need to find the UI for it. So let's split this pane, top and bottom. Right click on the tab here, go to Animation, Apex Network View. And if you try to hit tab or anything, you can see nothing happens. So to make a node in Apex, we need to have a node activated in SOPs that is a type of node that you can write to. And that node is stash. So this node Apex can write its graph to. And so let's just hit tab again. Now you see you get a menu here. You have lots and lots of nodes. Let's just go for a very common node when you're doing, for example, rigging. That would be the transform object. So this one. So now we have made our very first node in Apex. Yeehaw! If I middle mouse button on the stash node here, you can see it actually added a point. And you can see here we have a point. Turn on the visualizer. And if I go over to my spreadsheet tab here, you can see we have a position attribute, which you always have in SOPs. But then you have an attribute called transform object. And that's the same as the type here. So callback and type is kind of the same. You have a color. So what happens if we change the color of the node? You can see it also changed the value here. And our point, which is a bit hard to see, is now red as well. Interesting. Let's investigate further. So we have an attribute here called name. So if I rename this to root, for example, you can see now the name updates here. We also have an attribute called parms, which is a dictionary. Let's right click to inspect. And you can see it has a value or a key called S with this value and X for mask. So let's go to the node here and hit P to get the parms. You can see parms here have different colors. So the ones that we have specified here are black with a black background. The other ones that is kind of orange, brown, grayish color. And that just means that these values will revert to whatever is the default values for that parm. But you can always override more parms here by just adding keys and values to the dictionary using the same name as here. Okay. Then we have properties and tags. We'll get back to this in a later video. So now we can, for example, hold on Alt and click and drag to duplicate it. Let's call this spine 1, for example, and maybe give this a different color. Hit P to minimize the properties again, and let's connect these two together like that. If we now go to the scene view, you can see we actually have a line here. So what happens if we delete the connections? The line disappears and a line appears. And you can also see in geometry spreadsheet that we have vertices. You have the port name, xform and parent, xform and parent. It's very easy to see that the vertices that creates the line here are actually just the wire. So now you can see how the developers from SideFX have found this way to represent a graph as geometry. It's very important to point out that this is not Apex. This is just a description of how to build a graph in Apex. But this kind of traversion between geometry and the graph happens so quickly, so when you're using it, it kind of feels like it's the same. But also for later purposes, it's important to note that it's not the same. This is a representation. This is where the actual, let's say, calculations occur. All right, so now we established that any SOP node, it reads the geometry, it does some calculations to it, and then it outputs the result as geometry. But with Apex, we are building the logic and we are storing that graph or logic as geometry. So you're thinking maybe we could create an Apex graph starting with just geometry instead of starting in the graph UI. And you're right. So here I have an add SOP. I have 2 points. Again, a bit hard to see, but they're there. Let's add the callback attribute and let's use transform object as a value because we know that is a valid type and nothing happens. Now, if we just add the name, you can see we have 2 nodes. Awesome. You're probably noticing that these nodes have a different shade. They kind of faded a little bit. That means that the node we are viewing here, it has some information about a graph, but this node is not editable because the name SOP, it only sets the name attribute and you can't do anything else. So if I move this node here, I just reactivate the node, you can see this node is back to where it was. Nothing was stored when I edit stuff in the graph. To have our changes saved, we need to use a stash. Let's hit stash input. And now, if I go back and forth here, you see our changes are stored like that. But now we have broken the proceduralism. So here we are procedurally building a graph, and here I'm using SOP nodes. You'll see later that there are much better ways of doing this using Apex script, but that is for a later video, and we'll get back to that. There is also a node called edit graph, which is basically just a wrapper around the stash. Just has some error checking and auto stashing when you connect here, it automatically pulls in the Apex graph, or it pulls in the geometry, and then this UI reads that geometry and builds the actual Apex graph. In the next example, let's have a look at how we can actually output some values from our graph. So here I have an example again with the SOPs and VOPs. I just have a null, completely empty. I add an attribute called foo to the detail class. And here in the detail VOP, it's very simple. I'm importing this attribute. I'm adding a constant to it. So I'm just adding 2 to whatever value comes in here. And I save that as a new attribute called bar. And here in the detail tab, you can see we have our incoming original attribute and the result here. And if I dive in here and I, for example, change this, you can see the result over here is updating. So how do we build this in Apex? First of all, we need to plot down a stash or an Apex edit graph, and we need an input. So let's just write input, and we need an output like that, and we need an add of type float. So let's pipe this into A, that out there. Now we also need the constant, which is just called a value in Apex. Also float. Apex is very specific about types, so make sure your types are the correct for the nodes, the inputs and the outputs. And you can check the type by just hovering over a port and look at the bottom or the tooltip. So now input here we can rename to foo to match our example. So let's middle mouse button click, rename to foo. We could also output this to bar. And we can set the value here, hit P, to be 2 to match the example. So now we have a graph. If you go to the points tab here, you can see we have a point for each node in the Apex graph. And we have some vertices for the connections or the wires. So how do we get the result? We need to use a node called Apex invoke graph. And the first input takes the Apex graph like this. And then if you look at this and we check our detail here, there is nothing. So if you look in the graph here, we have an input called foo, but we haven't defined it anywhere. So we need some way of telling this graph that is being loaded inside of this node that we have an input called foo and pipe that value through to the add, and then we can see the result. So to do that, we can use a SOP called attrib adjust dictionary. And we can just type dict here and get this node. And by default, the name is set to params and the attribute class is set to detail. And that is what this node expects. So let's pipe that in here. And we need to tell it that we have a binding. And by default, this is set to params. We can now go here, scroll down a little bit, and we have to give it a key. So by the way, we have our detail dictionary here, but it needs to have a key called foo, and that key needs to have a value. So let's call it foo and set the value to be 1. And I did a mistake. The type should not be a string, it's a float. So again, let's set that to 1. And now we go to the invoke graph and still nothing. So what's going on? Again, Apex is very specific. It's a little bit low level, so to speak, to work with this node. So we also have to tell it what to output. So we want, in this case, just a dictionary. So let's add an output dictionary. And it should get the dictionary from the output node. And if I go here to the Apex graph, that's this node right here called output. And the output dictionary should be called params. We can call it whatever we want. But now if you look here, we have a dictionary. It has an entry called bar and a value 3. So now finally we can evaluate our Apex graph. And invoke and evaluate is pretty much the same. It is what the VOP node and every SOP node are doing automatically for you. It evaluates the code or the logic that is inside the node, and it outputs that as geometry. But yeah, we just spent like 10-15 minutes creating something you can do in 2 seconds with Vex. And if you're anything like me, this might be your thought right now. It was certainly my thoughts when I started out with Apex. I could not wrap my head around why this was useful at all. I've learned a bit more since then, but I'll try to summarize it with these 2 points, performance and framework. When we're using Apex, we are not really using SOPs at all. We are just using SOPs as a sort of convenient UX UI wrapper for Apex. So Apex is its own evaluation graph, independent of SOPs. So we are using the power of SOPs, which is really good at processing geometry, to create the Apex graph. And again, that's why we store the Apex graph as geometry, because we are working in SOPs. So in many ways, that's a little bit of a workaround to be able to use Apex efficiently in SOPs. But it comes with great benefits, and that is that you can build logic and compute graphs that are much more performant than you would ever be able to do in SOPs. And especially when you're working, for example, with VOP nodes, you do not have access to the inputs and output ports of nodes in upstream VOP nodes. Because the VOP nodes, they export out the data to geometry, and then your new VOP node downstream import that geometry and reads again the values of the attributes. But in Apex, you have the actual graph. So you can connect any port to any port no matter where you are in your node setup in SOPs. And that might be confusing. I will show an example in a bit. And the second point that I mentioned is the framework. And for most users, this is probably the most important. So SideFX is currently focusing on building up a rigging and animation framework, meaning some higher level tools for rigging and setting up an animation scene with multiple characters, constraints, etc. And the great thing about that is it's all built on Apex and it's a lot more user-friendly than what we have been doing here. And you might have heard that Copernicus is also based on Apex, and we'll probably see a lot of other great tools in the future based on Apex. Okay, so now let's go to the last example where we'll actually build something cool. This little guy. So here I have an example in SOPs. Let's have a look at that. We are just starting with platonic dodecahedron, probably not pronouncing that right, and I've made an HDA here that just takes the input geometry and we input the frame from here, just $F, and we have an offset value. So let's dive in again. That goes into these two parameters that then again is read by this parm node here. So here we get the frame, and let's show this one as well. And they are just added together with the offset, and again degrees to radians, a sine, so we get a nice animation. And I'm adding to make sure that the extrusion doesn't have negative values because the sine fluctuates between -1 and 1. And then here, this is just a multiplier for the effect or the distance of the extrusion. And that is saved out as this dist value that we then here in the poly extrude is reading from the detail attribute. And that's it. So then you have this first extrusion. Then we have the same HDA that just takes the result of this one and loops over all the prims and does the same thing. We could have also just have one of these and put it in a for loop, but for the sake of example, this is more clear when we're doing the same in Apex. And again, this is just to make the render a bit nicer. So adding normals and colors, beveling the edges a little bit. All right, so let's set this up in Apex. And to speed things up a little bit, I'm gonna copy this setup here and paste it over here. And for inputs, we want to match the HDA. So to start with, let's add the frame. So frame, and again, the type is float. And here we can add @frame so that this value will update with the same value as the frame we are on. So far, so good. The edit graph, we have input and output. We are going to use an add, but before that, we need to have a degree to radians. Let's add this here. And let's rename from foo, middle mouse button click, type in frame, so that this input here matches the key in this dictionary. Okay, so now we're getting the frame value in here. Now we want to run that through the sine node. We are getting a value out here between -1 and 1, so let's add 1. So let's change this to 1. And let's output this as result. Okay, on the invoke node, let's check here. We have the first input binding is set to parms. The first one here, this one is called parm still, so this is all working. We can check the geometry spreadsheet over in the details class, and we can now see that this result is now animated. So let's add the actual extrusion. So in here we are using the poly extrude. Let's just copy that one and paste it here. Oh, and let's delete that extra output node just to have it as a reference. So you can see the node or the parameter here that we are animating is called distance. And the name for the parameter is dist. And we have also changed the setting here from connected components to individual elements. And you can see that the text here is bold, so it means it does not hold the default values for this node. If you change it back, you now can see the text has the normal thickness. So let's go in here to the edit graph and add some space for the poly extrude. So we have a bunch of inputs here. These two first ones are of type geometry. So these are corresponding to the SOP inputs. Remember, in SOPs you only see inputs for geometry. Everything else is parameters, and you can use expressions to set the values, like here. In Apex, everything is just a port or an input. So first of all, we need to input the geometry we want to extrude. So we have to promote this one, because we want the geometry to be variable so we can input anything, like with HDA. So middle mouse button click, call this geo. You can call it whatever you want, but this is easy to remember. And we also need to set the dist parameter, or the dist input. So that is the result of the math we did up here, like that. We also need to change this parameter here called divide into, or split type, as you can see the real name is. And the real name of the parameter is what you see in Apex. So we don't see the labels, only the actual name. So we have one here called split type, and it's an integer. So if you go back here, you can see that this is an integer list. If you hold over here, it doesn't say it explicitly, but this is 0 and this is 1. So this should be 0. And let's go back to the Apex graph. You can see split type. It seems like it's set to 0, and this is very confusing at the moment with how the UI is. Remember, this color here means that the value is actually set to the default value of this node. And since this one is matching the SOP node, you can see the default value is this one, which is actually 1. So we need to just override that and type 0, and that didn't change anything. So let's try to toggle the value here and then set it to 0. That worked. So now it has this black background. It means we have set the value explicitly. And let's output the result here to, you can call it geo or maybe geo underscore out, just to have two different names here. We could also go here and say geo in. Again, it doesn't matter, but just to make it a bit clearer. Now in the invoke graph, if we look here, we have nothing, because we need to have some geometry as the input. Like this HDA, it has geometry coming in. So what we can do is simply to copy this node, make it the second input. And here in the bindings, we have added one entry to the bindings. So the first one is the first input of this multi-input port here. And we can add a new one, which is then pointing to the second input, which is this one. And we are not looking for a dictionary on this node. We are simply looking for the geometry. So let's check bind to geometry. And then we want that geometry to go into the geo-in port. So remember, on the input here, we have geo-in. So now this input is piped into this one. So then it's extruded, and then the result is piped to this output. And we also need to tell Apex to export or output the geometry explicitly. So we have here output geo out. So now finally we should be able to see the geometry here, and voila. It's running a little bit slow, so we could add a few more attributes to set the speed. That would be really easy. And I have an offset here so that the animations are offset as well. So let's just add a multiplier here from the input. Multiply float. Let's take the frame, put that into here, and let's promote this and call that speed. And now in our params here, we can just add another key, call that the same speed. again, we need to set the type, very important. And let's make it 5 times faster. And hit play. You can see now our animation is going faster. And like with this example here, we want to do this recursively. We can just add another invoke graph. I'm just holding down Alt and drag to copy it. And instead of inputting the same geometry, which will give the same result here, we can actually output the result here, which is geometry, to that same second input. I'm just going to take this wire here and put it into the output. And you see now we have a recursive, which is basically just a for loop doing the same twice. And now we have the same result as before. And I just quickly want to add the offsets so that the extrusion is not identical. We can simply take this one and just tweak, maybe just tweak the speed. If you want the offset as well, that is just add here before or after the multiply, it doesn't really matter. Let's take it before. So add float. Again, take the frame, take that to the result, and don't worry about these arrows. And then take the second one here, we can call this offset. So now we can offset the effect of the frames. So in this right here, we can make one called offset, set it to float, and let's offset it with maybe 50 frames. And now you can see the timing of the extrusion is different. Let's make it a bit less. And this looks pretty cool, I think. And now we can just add the same nodes as in the other example to tidy it up a little bit and make it look nicer. And we have something very similar. And let's hit play. Very cool. So as a little added bonus, I would just like to show what the real power of Apex is, and that is using Apex script. And let's just continue with the same type of build here. So let's copy the edit graph over, and let's make this a bit bigger again. Here, let's just grab all the nodes that does the logic we want to do, so excluding the input and the output. Hit this little button here to add them into a subnet, and let's rename this to extrude. If you check the geometry spreadsheet, we can see now that we have only 3 points since we have 3 nodes. And you can see there is one callback called subnet. So even if I dive inside of here, you won't be able to see in the geometry spreadsheet the contents. However, if I unpack the geometry here and we look at it, now we have all the nodes back on the same level again in the UI, and we have our points. So using subnets with Apex is very handy, and you can already see now a good example of why it's really tricky to use Vex to procedurally build your graphs and stuff from geometry, because you don't have access to all the nodes, and it's just not convenient. But that is exactly what Apex script is solving for us. Next part we want to do is just to delete the inputs and the outputs, because we don't want to duplicate the inputs and outputs. We only need one, and it will be added automatically by Apex script. So now let's add a merge. And basically what we want to do, and I'm going to do it manually here, put down an edit graph, is to, with a script, add inputs and outputs, and then daisy chain an arbitrary amount of these extrudes. like this, and then output the result. And for the sake of the length of the video, I have cheated and already set it up here. So let's just quickly go through this, and I promise we will get back to a more in-depth look on Apex Script in a later video. We have the same extrude here. I just added a copy node. I have not set it to pack an instance, just a normal copy. Then I'm just laying out the graph here so they are not placed on top of each other. And here is the node that I've been talking so much about, called Apex Script. And let's just quickly run through the code here. So I'm finding all the nodes called extrude, and with this wildcard, so extrude and anything else after, which means extrude and extrude 1 I will get. If I add a copy here, you see now it's called extrude, extrude 1 and extrude 2. So no matter how many copies I set here, these find nodes will give me an array of all the nodes. And then I'm looping over all of the nodes. For each node, I'm promoting these inputs. So that's this part for all of these nodes, promoting it to here. And I am, for the first node, I'm connecting it to the input. And if it's not the first node, like here, I'm connecting from the previous to the current. And then that just keeps doing the same over and over. So let's set it up one more. So now you can see it's only the first that is connected to the input. The next ones are daisy chained. Okay, and then for the last one, outside of the scope of the for loop, so this is always the last node, we are promoting the geo out, which is this one. And a little thing that is important to note, earlier in my examples, I had named the input and output ports to geo_in and geo_out. This is fine when you're just doing stuff manually. It's good to know that in Apex, this is actually part of the syntax. So when you have two ports that are named the same, you can fetch the input, writing the name and adding _in. And the same with the output, to have the name and then _out. So that's what this is doing. So it's actually a very good idea not to use _out or _in the namings if you want to work with Apex Script. And then lastly, I'm just laying the nodes out again. And this is giving us an updated graph. So again, the graph is just stored to geometry automatically. And this is a description of our logic. So to actually view the output, we have to use the invoke graph. So I just copied the setup from earlier, and I have the same inputs. And now if we play this, you can see we have our animation. And a little other thing I did was to just add this offset. So for each iteration here, we just multiply the duplicate ID, so 1, 2, 3, 4, etc. So there is a little bit of an offset to it per iteration. So the extrusion is not happening exactly at the same time. So now I can go up here and set this to 4. And now we have 4 iterations. And this is written out as a flat graph like this. And it's extremely performant, and it scales really well with, particularly with sort of rigging style computations, because we are dealing with a ton of matrices and separate nodes. And we don't want to run it in a loop. We actually prefer to write it out in a flat hierarchy. But Apex Script lets us actually type it as a loop. So that's a very important distinction and an extremely cool innovation that the development team have done here, which opens us up for a lot of great stuff in the future. So I'm really excited about Apex and Apex Script and the whole Apex framework. Really excited to see what comes next, and there is already so many things we can create with it. So I hope you'll stick around for the next video, where we'll have a look at how we can actually set up a character rig and animate it. Cheers and goodbye.
The only reason we can afford having Magnus spend a ton of time creating this course for you is the amazing support that we get from our patrons. So if you want to ensure that we can do stuff like this in the future and also get access to a ton of other courses about kin effects or Vex or Houdini in general, please consider joining our Patreon. And a very big thank you goes out to all our existing patrons. Without you, Entagma would not be possible. Thank you.